Last call. Anybody else? Any other takers? I'm going right now. It's just a quiz. I'll give you that one today.
I'm stuck at that.
Because when you complete the square, that
Thank you.
factors through. So you get
Well.
94.
Anybody else? Anybody? This is my choice of words. Clearly, because it's radicals, trigonometric substitution. See, I don't think that's a reason. I don't think just because I got radicals, I should be committing to a trigonometric substitution. However, I do think since I'm seeing some kind of square rooting involved, I mean, it's just a square root that a trigonometric substitution does seem to be the right way to go. So let's give it a shot. I mean, if I could just, I don't know, with my math D skills, massage what's in a radicand's position to look like a sum or a difference of two squares, then this really would be a prime candidate for a trigonometric substitution. So no calculus, math D. Let's see if you and I can't massage what's in the radicand's position in the integrand's position to look like a sum or a difference of two squares. Don't you agree that underneath the squared symbol, I got 2 minus some stuff? Or shall I say, I've got 2 minus some stuff. I'll just give myself a little more room. So I want to use no response. Can I complete the square next, at least inside the set of parentheses?
Yes.
Piece of cake. I think complete the square. I'm merely going to add the
1/4.
I agree. Shoot, it's not legal, is it? But you know, if you remove parentheses in the radicand's position, I think what I've really added within the radicand's position is a negative red beast, which is not legal. So I'll compensate by adding a positive red beast as well. And I think rewriting, that merely gives me nothing more than the integral of upstairs, sorry David, but the next, over downstairs, the square root of, I don't know, is that a 9/4?
Yep.
Minus a perfect binomial square, x plus 1/2 squared. Do you know what? I think we're right. That is a prime candidate. Let's give it a shot. I think the substitution I should commit to is that x plus 1/2 is, I don't know, I'll stop talking.
3/2 sine of x, or sine of theta.
And therefore paying the constant of my actions. Let's throw everything in. I think downstairs, you guys please tell me if I'm skipping too many steps. Downstairs, if x plus 2 is replaced with this, I think this whole second term is a 9/4 sine squared. I can pull the 9/4 out of both terms in the radicand, but pull outside the radical, and it becomes a 3/2. But that leaves me with the square root of 1 minus sine squared of theta. But that's the square root of cosine squared of theta. But that's just simply cosine of theta with the appropriate restrictions on the inverse sine function. I think another name for the numerator is merely going to be, actually I have no idea, what's that going to be?
It's going to be 9/4 sine of theta cosine of theta d theta.
For the numerator?
Right? Because you got x up there.
Thank you.
Ooh.
I got to work with the minus 1/2. So what do we do next? What's next though?
Isn't the dx wrong?
Fixed a mistake.
Yeah.
It's a big mistake, but it's a common mistake I see where I'm just replacing dx with d theta. Oh shoot, that's not true. Look. Dx got a whole bigger name or a whole more complex name than just simply d theta. Alright, I'll plug in that what I refer to as a scale change, and I'll replace dx with what it really is. You guys, only because I can, do you mind if I just be lazy and slash? Now personally, I probably would come in here and separate this into two completely separate integrals. After all, a mathematical axe, right there. I think the very first integral gives me a collapsing of the cosines. well, same with the second one. But all's really gonna be left over is, please watch my sign, is that negative 1/2 d theta? Is that a positive 3/2 integral of sine of theta with respect to theta? And now in anti-differentiating, I think that leaves me with a negative 1/2 theta increased by, well, how about I should say decreased by 3/2, is that cosine of theta plus c? Now you guys, yes or no? Do you like my answer?
No,
You know, whatever.
you got to back substitute.
Oh, mathematical etiquette. The original question was posed in terms of variable x. I'll go ahead and state my answer in terms of x. I'll back substitute. But in back substituting, the very first term is a 100% absolute piece of cake. It is a piece of cake.
2x plus 1 over 3.
Very nice. Of course, my second term becomes negative 3/2 times the cosine of theta. Okay, you guys, I got to stop. And in stopping, let me just take a pictorial break. If you can read my sloppy writing, it's a theta. I think that equation up there simply says the sine of theta is equal to the ratio of this to this. Or shall I say, if I were to embed theta in a right triangle, its sine is a ratio of this to this. Or shall I say, the length of the opposite side is the square root of the hypotenuse squared minus, well, this length squared. If that being the case, I could just take a peek at that pretty picture, identify exactly what the cosine of the angle theta is. It's the ratio of this to that. I'll say that again. It's the ratio of the square root of this mess to 3/2. Oh, look at that. 3 has canceled. Oh, actually, I did forget my C. So I don't know. Yes or no response. Does that look good enough to you? Yes. Everybody?
Yeah.
Yeah, I think it's okay. I mean, you can also say, well, in the radicand's position, we can clean up a little bit. After all, remember how I said the other day, typically you get what you started with in the squared situation? Oh, you can't see it. The computer turned off. Hold it. Oh, there it is, right there. If I were to expand everything in the radicand's position, I think it would look like this. I forget. The 2 minus x squared. But you know, either way. This way's nicer because you can see exactly what the trig sub was. This one's nicer because it involves no fractions. So I can't determine which one looks better. So quiet. Can you give me a show of hands? How many got that answer? Oh my gosh. 3 of you. This is the smallest odd prime number I can think of.
So, when you write sine inverse of 2x plus 1 over 3, if we were to say put the 2x plus 1 on the sine of that triangle and 3 on the hypotenuse, would that be incorrect?
It wouldn't. It's just that what you're going to see with the horizontal leg is exactly this.
Okay.
This looks different.
Okay.
But it's equivalent in the end.
Okay. Because I noticed there are multiple ways you could write that when
Absolutely.
you're doing the
And
sine.
you can say, no, there's got to be something wrong because 2x plus 1 is not the same thing as x plus 1/2 when you put in a value for x, and you're right. It's just when you look at the ratios with your trigonometric functions, the ratios will end up being the same.
Okay.
That's the only thing that matters. Anybody else want to tackle on this? Linda, you okay? Okay.
So if we neglected to add the 1/2 to to the x when we were doing the substitution for x, how many
you won't
points
do
is
that
that?
next week, will you?
Oh no, absolutely not. How many points is that? Or
Well, did you forget it over here?
Huh?
Did you forget it over here as well? On the next step?
the only place I forgot it was when I was substituting in for x.
Oh, so now
And then
down
they
here
made
you
it.
got sine of theta plus 1/2 squared.
I had 3/2 sine of theta instead of negative 1/2 plus 3/2 sine of theta.
That makes a big difference.
Yeah, I know.
I'm sorry. I'm sorry, sir. I didn't see your hand.
How do you effectively complete the square? Because that's what I always get stumped on. Your second step. Well,
I'll tell you how, but if when I say this, you saying this sounds like magic, tell me and I'll justify it. But here's my algorithm. So put on the special pair of mathematical glasses. You don't see any red, you only see black. I take the coefficient of x, which is 1. Cut it in half, give me 1/2. Square the result, give me
1/4.
1/4, and that's where the red beast came from. You guys, why?
Yeah.
Wow, what a good question. You guys, I know we need to take a break. Can I just address this one issue, then we'll stop? So you guys, check this out. I want a yes or no answer. Wait, Jesus. Using your math E skills, yes or no?
Yes.
Oh, 2 yeses. Everybody?
Yes.
Thank you. Let's do it again. It was so much fun. I'll just change the name of these.
Yes.
So I'm putting it asleep. Well, that was so much fun when you said it 4 times. X squared plus 2cx plus c squared. Everybody agrees is x plus c squared. Are we all there? Oh, I just forgot to put it in, sorry. Oh, I still messed it. I'm sorry. It was supposed to be c squared. I don't want to erase. Without erasing, I'll fix it. I'll divide that coefficient of x by 2, and I'll square the result since you guys seem to agree it should be a c squared. Did you guys see my point? If I only have the first 2 terms, and I want to create a constant out of thin air, so that I generate a trinomial indeed equivalent to a perfect binomial square, I'm going to commit to this red action. To these 2 terms, I'm going to add the coefficient of x, which you see in blue, cut it in half, square the result, so that effectively speaking, this constant really is just a c squared, which you guys agreed a moment ago I really should have right there, so that I do generate a trinomial equivalent to a perfect binomial square. Did you see it? And sir, that's why my little algorithm works. It's not math magic. Oh, by the way, something else. Notice that if what I'm saying is true, there is a condition that has to be met. Coefficient of x squared. And so in order to play this game, I always